Building software is rarely a clean, linear process because over time, complex code bases simply tend to get messy. Most systems move through a predictable life cycle, from inception to active evolution, but eventually they cross a threshold into a servicing phase, where the health of the system begins a sharp decline. This decay happens when experienced developers leave the team, business requirements shift, and the underlying technologies become obsolete. At this point, teams have to decide how to stop the software from collapsing under the weight of its own complexity. To prevent that collapse, engineers use the discipline of software architecture. This structural discipline focuses on a specific economic reality. As industry veterans like Robert C. Martin define it, the goal of architecture is to minimize the human resources, the actual time and labor, required to build and maintain the system over its entire lifespan. To maintain that efficiency, an architect designs the fundamental organization of the system. We view the system as a black box. Level 0 shows the program as a single unit, sys42. Through decomposition, architects break it into manageable white box elements, 1, 2, and 3. Lines D1 to D3 represent relationships, the specific dependencies dictating how they interact. The architect also has to account for the environment, everything outside the system, and the principles, which are the rules that govern the whole design. Organizing these components and their relationships systematically reduces complexity, turning a chaotic pile of code into a series of predictable interactions. Architecture work continues through every stage of development and operation, following the system long after the initial planning phase is over. This iterative cycle, design and decide, is how architects handle constant new requirements. They start by clarifying project goals and setting structural boundaries. As the surrounding clouds suggest, this loop incorporates patterns and technical concepts, which must be documented so the team can follow. During development, the architect performs a task called shepherding the implementation. They work with the team to ensure the software is built according to the documented vision, rather than taking shortcuts that degrade the structure. They also continuously evaluate the architecture to identify risks and verify that requirements like security and performance are being met. This involves deliberate trade-offs. Architects find compromises between conflicting goals, like choosing between high-speed performance and development cost, to avoid over-engineering the system. By managing these decisions in an ongoing loop, the architect guides the software through its entire lifecycle. While the design itself is technical, executing the discipline requires constant human communication. Architects act as translators for product owners and management, explaining technical risks and feasibility in terms that relate to business goals. They collaborate with domain experts to uncover hidden constraints and resolve conflicting requirements before the code is even written. Within the development team, they act as a coach, moderating technical debates and setting the standards for how different parts of the system talk to each other. To succeed, architects must adapt their language and documentation style for each of these different groups. Consistent documentation and clear system decomposition provide the clarity teams need to manage change. By maintaining these structures, architects ensure the system remains functional and cost-effective as technology and business goals evolve.